Let's take a look at solving equations using nth roots. Now, if we want to solve equations, remember our goal is always to get the variable by itself, and that does not change. But we just have to pay attention to a couple things as we solve situations where we have those exponents going on. So let's just go ahead and dig in. We start with this one right here. First of all, we need to get the thing that's to the power by itself. The 6 is not to the third power, just the x is. So I'm going to start by dividing by 6 on both sides. Then when I do that, that gets rid of the 6 that was being multiplied by the x to the third. And so we're left with x to the third right here. Now, 384 divided by 6, that gives us 64. Now, we're going to take the cube root of both sides because that's going to get that x by itself. That's the inverse. So I'm going to go ahead and take the third root of both sides, and then we're going to take a look at that. So this cancels out and gives us just the x, which is what we want, equals, and then the third root of 64. So what number to the third power gives us 64? Well, that would be 4. 4 times 4 is 16 times 4 is 64. So there we are. Now, something that you might remember if you've solved equations like this with square roots is that we always have to put a plus or minus out front. That's not the case in this situation. And let's just try it. If we had a -4 for our answer here and plugged it in, -4 times -4 would be positive 16, but then times another -4 would make it -64, and -64 times 6 would be -384, not positive 384. So the plus or minus is not the case. And we can generalize to say that if we have an odd root, we don't want to put the plus or minus. If we have an even root, we do need to put the plus or minus. So let's take a look at this next one right over here. For this one, we already have the thing that's taken to the exponent by itself. There's nothing else hanging out over here. And in order to get at that -8, we have to first deal with that. So in this case, we're going to go ahead and take the fifth root of both sides. Remember, we got to do this stuff on both sides if we want to solve these. And then that's going to leave us with just x minus 8 on the left here. And then on the right hand side, we have the fifth root of 100. Now, sometimes we can do some simplification with these. So we look for numbers that are factors of 100 that are something to the fifth power. So one option that we might have, let's see, 2 to the fifth is 32. That's not a factor of 100. 3 to the fifth, that's over 100. So no, there isn't any factors of 100 that are something to the fifth power. So we're just going to leave it like that. That's all we can do. But the x isn't by itself yet, so let's go ahead and take care of that. So plus 8, and then what's left over here? Just the x equals, and I'm going to put that 8 out front here, so we have 8 plus the fifth root of 100. And be careful, make sure that your roots there are coming in smaller than the numbers out front here, because otherwise it can easily be mistaken for 5 times the square root. And of course the square root of 100, well, we could simplify that. Okay, so let's take a look at this next one. In this one, we have a situation where we've got this part to the 7th power, and then we've got a -10. Well, before we take the 7th root, that's what it's going to take to clear this out, we got to take care of that -10. So let's do it. So we're going to add 10, do the opposite to get rid of that. So plus 10 plus 10. Then over here, we're left with x plus 2 to the 7th power, and that's equal to negative 2,197 plus 10 would give us negative 2,187. Then we're going to take the 7th root of both sides, because that'll clear out that 7th exponent there, taking that binomial to the 7th power. Do that on both sides. Then these are gone, and we're left with just x plus 2 equals, now this one right here, the 7th root of negative 2187. Might have to grab the calculator for that one, and I see that the 7th root of negative 2187 is negative 3. Okay, well that's not so bad. That works out nice. Then we're going to get that x by itself, so we got to subtract 2, and it gives us x equals negative 5. And there's our x. Also, don't forget, we could take that and put it back in for x and check it, make sure that our solution works in our equation. Finally, this last one right here, again, we have some other stuff here before we can get rid of that to the 8th power. And so we got to get rid of the 25. If we would take the 8th root right here, we'd get ourselves in a lot of trouble, because we'd be taking the 8th root of this whole thing, and that does not cancel that out. It just gets gross, so we don't want to do that. So let's get rid of the minus 25. So plus 25 plus 25. Then on the left, we're left with x to the 8th equals negative 10 plus 25 would be 15. Now we've got that thing to the 8th by itself, and then we're going to take this 8th root, I almost said square root, holy cow, and I'll tell you why in a second, the 8th root of both sides. Now, notice that this was the first even one that we did, and remember we talked about if we take an even root, we have to put that plus or minus out front, because that number could work as both a positive and a negative in our equation, because we would pair them up and there'd be 4 pairs of 2 negatives, which would become positive. So that would work. So this is all gone. We're left with just x equals plus or minus the 8th root of 15. And we look for things to the 8th power. 2 to the 8th is way too big for 15, so we can't simplify that, and we're all set. So, solving equations using nth roots. A couple things to remember. First of all, we have to get the thing that's being taken to the exponent by itself before we can use that root to get rid of that exponent. So in a situation like this, we had to get rid of the 10. Here we had to get rid of the 6. Sometimes it's ready, and we can go ahead and do that before we can get at the stuff that's inside the parentheses. Also, don't forget, if the root that you're taking is an odd root, then we don't have to do the plus or minus, and we talked about why that is. But if it's an even root, we do need the plus or minus, because both of those will work. I hope this video was helpful, and if you keep working at it, I know you can do this stuff too. Keep working hard on your math. Rock on.